Hey everyone, and welcome. Today, we're diving into a tool that is an absolute game changer for anyone serious about software quality, Selenium Grid. Seriously, if you've ever wondered how to take your automated testing from just a single machine to a massive, parallel operation, well, you are in exactly the right place. Let's kick things off with a problem that I'm sure every single developer knows all too well.
So picture this. You've been coding for weeks. You've built this amazing web application. And on your laptop, using your favorite browser, it runs flawlessly. It's perfect. But then, that little voice creeps into the back of your mind, right? Sure, it works for me, but is it going to work for everyone else out there on all their different computers and browsers? That is the million-dollar question.
And that question right there, it leads us directly to the core problem that Selenium Grid was built to solve, the huge, and I mean huge, challenge of cross-browser testing. The challenge becomes crystal clear when you look at what we call the testing matrix. And believe me, the complexity just explodes instantly. It's not just one thing. You've got users on Windows, you've got users on Mac OS, and you've got Linux folks. Then, for each one of those operating systems, they might be using Chrome or Firefox or maybe Edge. Suddenly, you're looking at this giant grid of combinations, and your app needs to work perfectly on every single one of them. It's a lot.
I mean, can you even imagine trying to test every single one of those combinations by hand? Forget about it. It's not just slow, it's pretty much impossible. You literally need a room full of computers and a whole army of testers just clicking around all day. There has to be a smarter way to do this, right?
And of course there is. That smarter way is the really elegant architecture behind Selenium Grid. And it all boils down to a super simple concept: the hub and the node. All right, let's start with the hub. The best way to think of the hub is as the brain of the whole operation. It's like an air traffic controller or the project manager. It's the one central place that receives all the test requests. Your scripts don't have to know where the tests will run. They just talk to the hub, and the hub does all the smart work of figuring out where to send them.
So, if the hub is the manager, then the nodes are your team of specialists. They're the workers on the ground. Each node is just a machine. Could be real hardware, could be virtual. And it's set up with a very specific environment. You might have one node that's macOS with Firefox, and another that's Windows with Edge. They basically check in with the hub and say, hey, I'm here, this is what I can do, and then they just wait for an assignment.
And understanding this distinction is absolutely crucial. You have only one hub, the manager, but you can have many nodes, dozens, even hundreds if you need them. The hub delegates, and the nodes execute. And that, right there, is the secret sauce. That's what gives the grid its power to run tons of tests in parallel.
Okay, so let's walk through how a test actually runs. It's a really simple flow. First, your test script sends a request to the hub. It says something like, hey, run this test for me on macOS with Firefox. Next, the hub gets that request and scans its list of available nodes to find a match. Aha, here's one. Then, the hub forwards the test command to that specific node. Finally, the node gets the command, wakes up, opens Firefox, runs through all the steps, and reports the results back. It's a beautifully efficient system.
All right, so we keep talking about this army of worker nodes. But what are they, really, in the real world? And has the way we build them always been the same?
You know, the way we create these test environments has really evolved over the years. Back in the day, you needed actual physical machines for each node. Can you imagine? It was incredibly expensive and a total nightmare to maintain. Then things got better with virtual machines, or VMs. That was a big step up, but they were still pretty heavy and slow to get going. Which brings us to today, Docker containers. These things are an absolute game changer. They're lightweight, totally isolated, and can start up in seconds, making them perfect for a dynamic and scalable test grid.
And when you lay the options out side by side, the choice becomes, well, pretty obvious. Just look. Physical machines, the cost is through the roof, setup takes days, and scaling is awful. VMs are better, but still pricey and take hours to spin up. Then you've got Docker containers. Low cost, setup time in seconds, and excellent scalability. It's a clear winner, and it's why all modern test infrastructure is built on container technology.
Now, for the final piece of the puzzle. We know the what and the why, so let's talk about the how. How do you actually get a Selenium Grid up and running? Well, there are two main ways to do it.
First up, we have standalone mode. Think of this as the easy button. With just one command, your own computer becomes both the hub and a node. It's absolutely perfect for learning or just doing some quick practice locally. Then you have the real deal, distributed mode. This is the setup for serious large-scale testing, where you have one dedicated hub machine and lots of separate node machines connecting to it from all over.
And when I say standalone mode is easy, I'm not kidding. It's literally 2 steps.
You download one file, the Selenium server jar, and you run a single command in your terminal. Boom. That's it. Your local grid is up and running, ready to go.
The distributed setup has a couple more steps, but the logic is super clear. You start the hub on its own machine. Then, on each of your node machines, you run the node command and just tell it the address of the hub. They automatically connect, and just like that, you're building out that powerful multi-machine testing army.
And really, when you boil it all down, the whole philosophy of Selenium Grid is about working smarter, not harder. It's not about just buying more physical computers, no way. The goal is to intelligently use the resources you have, whether they're VMs or containers, to scale your testing capabilities as efficiently as possible.
So that leaves us with one final thought. You now get the architecture and the why behind Selenium Grid. The real question you should be asking yourself is, how does your current testing process stack up? Is it really built to handle the complexity and the scale that modern applications demand? Something to think about.